Hello, class. This is the video for section 5.1. Now, as you know, we are beginning chapter 5 this week. And we have, after this chapter, one section in chapter 11 and one section in an appendix, and then the class is over. So we are getting closer to the end of the semester. And chapter 5 talks about exponential and logarithmic functions. Before we define the exponential and the log functions or logarithmic functions, we need to define other functions like composite functions, one-to-one functions and inverse functions and all sort of that. So this week we are looking at sessions 5.1 and 5.2, and we will do some of those definitions. Okay. All right. The 5.1 talks about composite functions, and the following are the learning outcomes. We want how to form in a composite function and then find the domain of a composite function. All right. And let's just say definition, a composite function that's given two functions, f and g, all right, f and g. The composite function denoted by this, it says f small 0 like a degree, g, is read as f composed with g, or you can say f of g. I'm going to use this frequently because that is kind of shorter. F composed with g or f of g, all right? It's defined as if you have f of g of x, it means that evaluate the function g at x, then put the results into the function of f and then evaluate it. Okay, the domain of f of g or f composed with g is a set of all real numbers in x in the domain of g for which the g of x is in the domain of what? In the domain of f. Okay, so that's the definition for the domain, finding the domain of the composite function f of g. Again, it's a set of all real numbers x in the domain of g for which the g of x is in the domain of what? F. Now, diagrammatically, okay, we have this. Now, this is the domain, okay? The domain of g is taking the value x, all right, and put it in and give it the range, all right? And then the f of the function f takes the what, the result, and put it in the what, in the final what, output. So we have an input, we get and then an output, and then the function f takes the input of, sorry, the output of g, and then produce and what, an output. So the input of f is what, the g of what, the g of f. And so this whole process is what we call, is what, the f of g. Now, as you can see, the domain of f of g, okay, is a subset of the domain of what? The domain of g. And then the range of f of g is a subset of what? The range of what? The range of f, because f is the degree. Okay, so in a real life, you can see that in a production line, okay, the one machine, let's say machine number one, you give an input and brings us an output and gives it to the next machine to process it. So this kind of process is what we call the what? Composite word function. All right. And we can have a more, this is just the basic, we can have more than 3 functions involved. I can have another function h that would take what, this result as one input and bring out what, an output. All right. Now, let's take some examples. Say evaluating a composite function. Suppose that f of x is what? Fx, 5x minus 1. And g of x is 3x squared. We want to find a, f of g of 1, and then b, f of g of 1, and then f of f, that is the function composed with itself, that is at negative 2, and then g composed with itself at negative 2. Okay, so we want to start with the first one. Now, f of g of 1, meaning that we are going to plug in 1 into the function g, and then the result, we put it in what? The function f. So our g of x, f of 1, is what? 3 1 squared, which is what? 3 is 3. And so this is equal to f of what? F of 3. So the 3 that we got, we plug it into the f. So into the f will give me 5 times what? Because f of x is what? 5x minus 3 minus 1. So 5 times 3 minus 1. And that gives me what? That gives me 14. All right. So the f of g at 1 is equal to what? Is equal to 14. 1, 4. Okay. All right. Let's go to the next one. Okay. G of f of 1. So if you have this will be g of what? F. We first evaluate the function, evaluate the function f at 1, and then put the result into what? Into the g. All right. So f of x, f of 1 in this case is, because my f of x is 5x. So 5 times 1 minus 1, and that will give us what? That will give us 4. And so this becomes g of what? Of 4. All right. See that? The output of the f gives me the what? The input for the g. And then this is 3 times 4 what? 4 squared. Okay. And that is equal to, you get 3 times what? 16. That is equal to what? 48. Okay. And then f of g, f of negative 2. This is what? F, and then f of what? Negative 2, like that. Okay. First, let's evaluate the function f of 2, f at 2. And that gives me negative 2, it is minus 2 minus 1. And that gives us what? Negative 10 minus 1, which is what? Negative 11. Okay. So then that gives us what? F at negative 11 again. So we have what? 5 times minus 11 minus 1. And that will give us minus 55 minus 1, which is equal to negative what? 56. Okay. So that's the answer. Okay, good. Now let's go to the last one, g of g. That is g composed with itself at what? Negative 2. So that's just like we did for part C. This will be the g at, we evaluate the g at what? Negative 2 first. Well, my g of x is that. So g at negative 2 is equal to 3 times negative 2 squared. This is what? 4. And give us 3 times 4, which is what? Which is 12. So we go in and plug in again into the what? That gives me 12. Evaluate the function g again at what? Negative 12. So this gives us 3 times what? 12 squared. And that is 3 times what? 144. Okay, now 144 times 3 will give us, we have 3 times 144, and that is what? 432. So to give us what? 432. All right. So that is about evaluating the function. Composite what? Composite functions. All right. Now let's go to the next example. Finding a composite function in its domain. All right. So we are given the function f of x as what? X squared plus 2x minus 5. And the g of x is 3x plus 1. Okay. A, we want to find a composite function f of g, and then also g of what? F. Okay. Now, don't think that this is multiplying. Okay. F of g is not the same as f times g. Okay. And then g of f. Okay. Note that the g of f is not equal to, let me erase that. Okay. So don't think that the g of f is not the same as g times what? G times f. Okay. They are not. So take note of that. All right. So we want to find this function a, and then find what? Their domains. All right. Okay. Now remember, the domain of f and the domain of G are the set of all real numbers in this case. Okay, this is a polynomial. That's a quadratic function. That's what? A linear function. And so f of G, the domain of f is what? All real numbers. The domain of G is also all real numbers. Okay, so what would be the composite function of that? Okay, so now let us find this function, f of what? G. Okay, so wherever we see what f, let's put the f here. I think I have there. F is what? F is a function x squared plus 2x minus 5. And the g of x is what? 3x plus 1. So wherever we see what? X in f, we plug in this whole expression. That's g of x. So we have for x squared. So that's 3x plus 1 all squared. That is x squared of the f. Then plus 2 times x. So we plug in what? The g of x, which is 3x plus 1, and then minus what? Minus 5. And so when we expand this gives us what? 9x squared plus 6x plus 1 for the first term, then plus 2 times 3x, that gives me 6x plus 2 minus 5. Okay, and so this is 9. Okay, so that gives us what? 9x squared, then 6x plus 6x is what? That is 12x. 1 plus 2, that's 3 minus that is what? Negative 4, negative 2. Okay, so you see that this expression is also a polynomial or a quadratic function. All right. So what's the domain of that? It's all real numbers. Okay, so that's why we have that expression. Okay, 9x squared plus 12x minus what? Minus 2. So then, because the domain of both G and F are the set of all real numbers, in this case, the domain of what? F of G is also the set of what? All real numbers. All right, now let's go to part B. Part B is a G composed with F. Okay, so wherever we see the what? So this is this time the first is the F. We plug the F into what? Into the G of X. So the G of X is 3x. Remember, it's 3x plus 1. So we have 3x, all right, x plus 1. So whatever with this, what goes in here will be the function, the whole expression of what? F of x. And so that is what? X squared plus 2x minus what? Minus 5. And this gives us 3x squared plus 6x minus what? 15 plus 1. Okay, so that gives us what? 3x squared plus 6x minus what? 14. All right, so that gives us that expression. So what does it mean? It means that we got this expression here, which is also quadratic or a polynomial, right? Quadratic function. All right, it is quadratic function. And so what's the domain of that? Again, the domain of what? F and G are what? Both are real numbers or the set of all real numbers. And therefore, the domain of a G of F is also the set of all real numbers. Okay, so this example then gives you, it is easy to find the domain, but whatever you have, because both functions are polynomials, okay, they fall under our polynomials, and the polynomial function, the domain is what? All real numbers. That's why the composite function is all real numbers in these two cases. But the next example is different. When you have involving rational numbers, it's different, and then we're going to look at it separately. All right. So here's a remark. It says, in determining the domain of the composite function f of g, okay, of x, which is equal to what? F, then you plug in what? G of x. Keep the following two thoughts in mind about the input what? Input x. All right. Now, any x not in the domain of g must be excluded. Okay. Any x not in the domain of g must be excluded. And then 2, any x for which the g is not in the domain of f also must be what? Excluded. Okay, there are 2 ways we do this, and I'll show you in a minute. Okay, so here we want to find the composite function f of g, where f of x is a rational function, 1 over x plus 4. And g of x is also a rational for 4 over x minus 3. All right. So option 1 goes through this process. First, we will find this function for this the composite function given. First, note that the domain of g of x is what? It's all real number except what? Positive 3. Okay, so that means that you take the denominator. You don't want the g to be divided by a 0 number, so you equate it to 0, and then you get x is equal to what? X is equal to 3. Okay, so that 3 must be excluded from the domain of what? F of g. And then the second, let's note that the domain of f doesn't include what? So again, s plus 4 equal to 0 is equal to negative 4. All right. So notice that it's just like finding the what? The vertical asymptotes. Okay, in chapter 4. So this means that we want to find the values of x for which the g of s is not equal to what? Negative 4. It's not equal to. So that means it cannot. So how do we approach that? Okay, so we take the g of x and set it to what? Negative 4 and solve that. And then all the values that we get, we exclude it from what? The domain of the composite function f of g. Okay, so, all right. So what is our g of x? G of x is what? 4 over x minus what? S minus 3. So we set it to this and solve. Okay, so that gives us what? 4. You cross multiply. This will be negative 4 times x minus 3. And this is equal to minus 4x plus 12 equal to 4. Okay. And then you get what? Negative 8 is equal to minus 4x. All right. And then you get x is equal to what? X is equal to what? It's equal to 2. All right. So what is the domain? With the domain of the f, the composite function f of g will exclude the value of what? We'll exclude the 2 as well. All right. So exclude 2 from the domain of what? F of g. And then, therefore, the domain of f of g is equal to what? Is equal to that. Okay, that is one option. All right. You don't want the g of x to exclude the values such that the g of x is not in the domain. The g of x is in the domain of f. So you note the values for which the f is undefined, set it to g of x, and then solve, and then exclude those what values. So that is one. Okay. The other approach is we know the domain of g, then we find the composite function and look at that composite function and consider the denominator. It cannot be divided by what? 0. So first, option 2, we want to find this function. So first thing, do that. Okay, we know that the g of x that's the domain. Okay, again, same explanation as before. So we exclude 3 from the domain of the composite function. And then the next thing is that we look at the g of x, all right, and then exclude values of x that make it undefined. In other words, there is a result in what? Division by what? 0. Okay, so first we're going to find this and see how that expression looks like. And then the domain, to look at it, find the domain of that, and then also exclude those values from what? The domain of g of x. Okay, so here we go. Okay, what is our f of x is what? 1 over x plus that. So first we have for f of x is equal to 1 over x plus 4. And then g of x is what? 4 over x minus 3. And so the composite function, okay, is equal to f of what? G of x. So that means that wherever we see x, we plug in what? The g of x, right? So f is what? 1 over f of x plus 4. So plus what? Plus 4. But it's going to be the g of what? G of x plus 4. Okay, because my x is what? Is that. Okay, so that gives me 1 over, okay, 4 over x minus 3, then plus 4. Okay, so then we have to simplify the denominator, which will give us 1 over, okay, to have a common denominator for the denominator. This is plus, you multiply the 4 by what? The x minus 3, and also divide by what? X minus 3. Okay, so that you have the denominator is still 1, and then you have what? 4 plus 4 times x minus 3, all divided by x minus 3. Okay, so then what do we have then? You have all 1 over, okay, the 4 plus 4 times 3 is what? 4x. 4 times x is 4x, and then 4 times minus 3 is negative 4, 12, divided by x minus 3. Okay, so when you look at this, you have 1 over, all right, 1 over, that should be 4x minus what? Minus 8, all divided by x minus 3. Now, you want to see this as 1 divided by 4x minus 8 over x minus 3, which is equal to 1 times, that's the fractions, x minus 3 over 4x minus 8. So the expression g of x, sorry, f of g of x is equal to x minus 3 divided by 4x minus what? 8. Okay, so you see that we don't want the denominator to be 0. Okay, so we take that, we take 4x minus 8 equal to 0, and solve for what? Solve for x, and that x is equal to 8 over 4, which is what? Which is 2. And so the domain of the composite function f of g, okay, is what? It is x such that x is not equal to 2 and not equal to what? 3, where 3 is from the what? The domain of what? The g of x. See, we got the same as what? Before. Let's go back and I'll show you. This is what we got last time. For the option 1, see that the same domain as we got over there. Okay, very good. All right, so then let's look at the next example. All right, we want to find the same expression is similar to that. We have f of x is 1 over x plus 3. G of x is what? 3 over what? X minus 2. We want to find the domain of the composite function f of f, that is f composed with f, and is what? Is domain. Okay, so first, what is the domain of what? What's the domain of f? Okay, what's the domain? Domain of f is what? It doesn't include. Okay, and when x is equal to negative 3, it is 1 over 0, which is undefined. So it shouldn't include. The domain of f cannot include what? Negative 3. All right, and then we use one of the options there. We set the same function to itself to the negative 4, 3, and get that. Okay, to find the domain of the composite function f of f. Okay. So to find the other number to exclude, we solve the equation. All right, we solve the equation at 1 over what? 1 over x plus 3 is equal to negative 3. All right, so when you solve this, so this will be 1 over, okay, cross multiply, it will be equal to negative 3 times x plus 3. And then that gives you 1 is equal to negative 3x, all right? And then minus what? Minus 9. Okay, and then when you add 9 to both sides, you have what? 10 is equal to negative 3x. And so x is equal to negative 10 over what? Over 3. Okay, so the domain, So f of x is not equal to negative 3, meaning that this is equal to minus what? Okay. X cannot include what? Negative 10 over 3. And so we have the domain of f of g as that. Okay. Now, we can, that's just curiosity. Let us find f of f. I don't know why I'm writing g. I kind of writing that many times. So, all right. Okay. So let's find f of what? F of x. So we're going to do f of what? F of x. All right. So where we see f of x, we plug in f of x. Now notice that f of x is what? 1 over x plus 3. All right. So when we have that, this is equal to 1 over x plus 3. We plug in the same expression, 1 over x plus what? 3, then plus what? Plus 3. Okay, so just like we did, we simplify this. We multiply this by x plus 3, and then also x plus what? 3. And then that gives us 1 over, okay, 1 plus 3 into what? X plus 3, all divided by x plus what? 3. Okay, and that will give us 1 over 1 plus 3x plus 9. That gives us what? 3x plus 10 divided by x plus what? 3. And then you flip that, that will be x plus 3 over what? 3x plus what? 10. So if I use the option 2, notice that you technically take that and set it to 0. You get 3x plus 10 equal to 0, and get x is equal to negative 10 over what? 3. And so the domain of the f of f will exclude negative 3, and to also exclude what? This value. So whether you use the option 1 and 2, you will get the same what? Results. All right. Okay. So that's what I'm explaining here, that the domain of f of f also can be found by noting that negative 3 is not in the domain of f, and so it's not in the domain of f of g. Then looking at f of g, that's we express, so f of f, I don't know why I'm saying f of g, is x plus 3 over 3x plus 10, okay? And looking at that and set that to 0, and that see that it's not also equal to what? Negative 3, and therefore the domain will be the same as before. All right. Now, it says showing that two composite functions are equal. Now, we are doing this on purpose because the next section, 5.2, okay, will need some of these things, okay, for you to find. I'm not going to give it to you yet, but it's something that is very important. Okay, now here we have f of x is what? 2x minus 5. G of x is x plus 5 over 2. We want to show that if we do composite function, compose f with f, f with g, and then compose g with f, you will get the same what? X. Okay, for every x in the domain of both of them. All right, now let's see. Okay, so first, what is f composed with g? Okay. Oh. Okay, this is equal to, all right, wherever we see x in f, we plug in the whole of what? G. Okay, so this is 2 times x minus 5. And then what goes in here is what? X plus 5 over what? Over 2. Okay, so when you simplify this 2 will cancel that 2, and you have x plus 5 minus 5. And that is equal to what? That's equal to x. Okay, and then we do it for what? We did it for the g of f, or a g composed with f. All right, so what would this equal? Okay, what is g? G is what? It's what? X plus what? Plus 5 all over what? Over 2. Okay, so f of what do you call it? That's right here. G of x is what? X plus 5 over 2, and then the f of x is 2x minus 5. So whatever we see x, we're going to plug in what? The f of x. All right, so this is equal to 2x, right? 2x minus 5. That is your f plus the 5 all over what? 2. And that gives me 2x minus 5 plus 5 all over 2, which is what? It will be 2x over 2, which is what? Which is x. Okay, so you see that if you compose f on g, f with g, and then compose g with f, you get the same what? X expression, which is x for every x in the domain of both of them. All right, so we conclude that, okay, we conclude that for every, okay, we conclude that g of x, f of g, and g of f is equal to 1, is equal to x, and x is any real number. So in section 5.2, we shall see that there is an important relationship between the f of g for which this is what? This is true. Okay, for which this is true. Okay, so now let's go to the next one. Okay, this time we're going the reverse. They've given you the composite function. You want to decompose it. In other words, you want to find the components of what? The composite function. Okay, here example said the functions f and g, we want to find them such that the g f of g is equal to h, where h is what? H is this. Okay, now notice that now the h of x means that we have raised this expression by what? So there's a function that when we plug in a whole expression 3x squared minus 5 to give us what? The h of what? H of x. So the function h raises the expression, okay, 3x squared minus 5 to the power 21. Okay, so a natural way to decompose h is to raise a function, okay, g of x to the what? To the negative, so the positive for 21. Okay, so that means what is my f of x? F of x, you can let f of x be what? X is equal to 21, and then g of x is equal to that expression. Now, sometimes we'll be calling this the inner function and then outer function, all right? So if that's the case, let us figure out whether this is true, right? Okay, g of x is that. So let's just find this expression. X is x, f of x is what? X raised to what? 21. So we have what? This raised to 21, x raised to 21. And then in place of x, we plug in what? 3x squared minus 5. So 3x squared minus 5. And that is the same as what? It's the same as what? The h that we got. Okay, so we plug in that, and that gives us what? The same expression. This is equal to what? It's equal to h. Okay, and then finally, all right, we want to decompose same, find f and g such that h is equal to the composite function that. Okay, now as you can see, look at 1 over x plus gh of s is equal to 1 over x plus what? X plus 3. Okay, so how we decompose that here, h is a reciprocal of this expression. Okay, it's a reciprocal of the expression. And so we can let f of x is equal to 1 over x, and then g of x is the same expression, 3x of x plus what? X plus 3. Now, if that is the case, then let's find this expression here. This is equal to, okay, is equal to 1 over the g of x. Okay, and what's the g of x? The g of x is what? 1 over what? X plus what? 3. And basically, this is equal to what? Is equal to the h, which is this expression right here. Okay. So with that, that brings us to the end of what? This expression, this section, this video, and I'll see you in few minutes for the next one. Thank you.